So integrating quantum computing hardware into data centers comes with challenges. We're taking devices out of physics labs and putting them into server rooms. Picture an early classical computer, a huge machine with its glowing vacuum tubes, masses of cables and clunky storage devices, and compare that to a modern server. The early systems needed to be constantly tended to, while the latter can run completely unattended. A modern server is happy running just about anywhere. It adapts to fluctuations in power and temperature, while early systems were always right on the edge of failing. The state of many quantum computing systems today resembles those early classical computers, and the development will follow a similar path. Today, the quantum computers themselves are the size of several full server racks, but as vendors create more specialised electronics to replace the pieced-together lab equipment, they're constantly shrinking. While vendors work on making their quantum computing systems more robust, we also have to tackle the problem of environmental requirements at the other end, that is, in our server rooms. We're seeing quantum computing systems today that require more stable humidity and temperatures than classical servers do. We have to consider issues like shielding machines from magnetic fields and vibrations. Quantum effects only being visible at such tiny scales means that they require isolation from their environment. We literally have to consider individual atoms and electrons coming into contact with our qubits. To this end, we currently run cryostats in our server rooms, where we cool superconducting electronic devices down to only thousandths of a degree above absolute zero. The average system administrator hasn't been trained in the operation of advanced refrigeration systems, or in the handling of things like helium gas and liquid nitrogen. In the medium term, we're going to have to teach our operators these skills. But we're not only installing quantum computing systems in our data centers, we also want to integrate them with the classical high-performance computers that we already operate. So another challenge that we are working on is to design and build the software and the interconnects that allow these two different computing paradigms to interact effectively.